my name is Dale Swanson. I'm a mechanical engineering major and a German major, and I am a junior here at GB. This is my project. I decided I wanted to do a model rocket, and why I wanted to do this, I'm super into like aerospace. I want to go to my master's for aerospace engineering, so I thought what better of a project to do than a model rocket. This is a little different than just a regular model rocket though. I wanted to build something where you could control the flight path, so whether you control it using the fins or wings, you could preset that beforehand, or you could do it after the fact or during the fact. And so with that, I decided I wanted to make movable wings and fins here, so these two things can move here. I used a lot of ideas from like NASA and SpaceX as inspiration. And the main idea, like I said, was to control it, because a lot of times when you're younger and you build those small little plastic ones, they're cool with the sugar rockets, but they only go up and they come back down with a parachute, and there's no electronics on it. You can't find it half the time. You can't control it. So the idea is that you have these wings here that are able to move in unison with each other, so that you can move it through the air and determine its flight path. And these can move up here. These canter back and forth like that. So that's more for guiding on its way down, if you wanted to save the rocket, or you can use mid-flight as well as another aid. The biggest struggle I had was figuring out these wing designs. So if you look closely here, the idea behind it is that there's this one attachment part that goes into the rocket, and then ideally, if you look in here, there's open space in here. However, if I were to actually build this in real life, I would use like Arduino boards and code these Arduino boards and make sure that you can just designate a flight path through a certain area or whatever. And then using this system here, I could have wires from the parachute down to the fuel tanks and such like that. Like I said, the biggest struggle was finding out this design here. So I actually used a loft to pull these, or to like have these at this angle here and pull these down. And then everything on here is straight and sharp, except for just this small little piece here, which with the motor I have on it, this is negligible for the aerodynamics. Ideally, this would be sharper. However, in this small of a system, it's kind of negligible. So if I go around and I can show you the different parts of this, actually I'll leave that transparent. So for the extrude, I usually extrude on most of these pieces, but for the main one, I used it for the whole rocket body. And then for the revolve, if we look down here in this base piece here, you can see that if you draw this out like that and come back here, you can revolve it, and that's what I made for that piece there. For the sweep, I actually really liked using this tool. I used it for this tubing. So this is actually hollow tubing here, and ideally there'd be more of this, but for now I just have the one in there connected from the parachute to the fuel tanks. And more of this could be used for wiring with those Arduinos, as I mentioned, or they could be used to connect these two tanks together. And ideally you'd use like Kerolox, which is a mix of fuel with oxygen and kerosene here. For the shell, I actually just shelled the inside of this rocket body a little bit, so that you could have all that open space in there to put this anchor down, the parachute container, all the exhaust, and the fuel tanks in there. For the pattern, this was really cool. I actually used that for the holes on this fin here. So I actually filleted a hole and put this along these fins here, so it's more aerodynamic as that air can go through here. And for the sheet metal, I actually use that for the base here on these clamps on the bottom. So the biggest problem with these bases is that with the plastic ones, they can get launched all over the place, or if they're the super light ones from the boxes, those get tossed out, broken. The idea of it is reusability, and it's more safer anyways. So you could, in an idea, this could be a reusable rocket if you saved it and found it, and then you could reuse this base over and over again. This is made out of aluminum here, and then these pieces will keep it secure to the ground, whether that's on grass or if you actually have a designated spot to put it in wood or like the ground or something like that. For the flex, I just used the flex on the guide arm here. This guide arm actually sits on the side of the rocket, so I'll actually make this not transparent. If you see, there's a guide piece here. This would sits on here as it just rests, and I use a flex to keep that tension on it so it doesn't move. And as this rocket would take off, this piece would move up like this and get out of the way. For the surface, I used the surface as the exhaust nozzle. I had two planes, and I drew them, and then I offset the entities and made it about 5 millimeters thick. This is made of some nickel alloy, which is the strongest material. It can withhold or withstand a really high temperature. And then for the new feature, actually, if we look back into the rocket here, I used a wrap feature for the parachute name right here. And I'll make this less transparent, and I'll actually just show you the motion study on this thing. So there we have the wings that can canter back and forth together. And if it moves up here, we'll see I added a little payload door there we could add for space to carry some things. Here's the fins as it moves through the air, as they can canter back and forth. And like I said, those can aid with fall or on the way up. And then finally, there's that final piece on the back there. Yeah, and that's my project. Thank you for watching.